Okay, last two questions on this exam. First one, number six, I found to be part of it is easy, part of it's difficult. Again, they're giving you a situation which they said, consider the value of k. Now, what you're supposed to see here, and this threw a lot of students on the original AP, is it is when they say consider it, they're saying look at it. Is it a big number or is it a small number? If it's a big number, it means it goes to completion. If it's a small number, then you're going to probably have to do an equilibrium calculation because it's not going to completion, right? 10 to the seventh power is considered big. That means you got like 10 million times more product than you have reactant when you get to this thing. And the coefficients of all these guys are ones. Okay, so nothing's getting squared or cubed to mess up that really simple assumption. All right, and then it says consider value k. Determine the concentration of BAEG. So this is basically a stoichiometry question. And this kids couldn't figure out what to do with this because they saw the equilibrium constant. If the equilibrium constant is big, it's a limiting reagent problem. Figure out how much product you get. Okay? That's all they want you to do. Assume all the reactant turns into product. Now, is that really true? No. But to the number of sig figs they want here, it is true. The amount of reactant will be 0.00000 something that's left. Tiny. The second part of that question, okay, it says the solution is diluted with distilled water, okay? And then it asks you the concentration of the number of moles of ions. Look, whenever you dilute something, okay, think about this. Does it cause more or less of the stuff to dissolve or form ions? Okay, that's how you should look at this. Dissolving is a general physical process which always leads to a change in the concentration. If you have some sugar at the bottom of a container, right, and it's a saturated solution and you add some water, right, what's going to happen to that sugar? That's literally what this question is asking you, okay? You can do a lot of math here, but you don't even need it. It's a general principle of chemistry that when you dilute a solution, if it's saturated and the solute on the bottom, something's going to happen to that solute. Next question. All right. Again, it's an acid-based question, but the first part really is more of a math question, so I think it's worth expecting you to do this one. All right. A 25.0 milliliter sample of an unknown monoprotic acid and determine the concentration by titration. Student used standardized 0.100 mole NaOH. Okay, not going to be on your AP exam, but just to have a little talk about this, this is really a sig fig question, I'm sure of it, okay? They want you to figure out what volume the NaOH is being delivered to the flask. They want you to do the measurement properly. Now, that would be on this, no doubt, okay? You're supposed to realize that this is going up by 0.1s, which means you should measure all volumes out to the hundredths. And that's something that I teach to, I can't spell hundredths. I think that's right. If it's wrong, I'm sorry. You should be able to, hundredths, yeah, that's correct. So you should measure all volumes here to the hundredths, and that should indicate how much NaOH you use. And that's not something that should be, I mean, they could do something else. We had to measure it. You should know if this is going, if the scale is going up by tenth, you should measure to the hundredths, and that should indicate how many sig figs there are in your final calculation. It says determine the concentration of the acid that should be recorded. This is a situation which you could just use MAVA. MBVB, and the reason why is because it's a monoprotic acid and it's a monohydroxy base, all right? And so you just be plugging in values. They gave you the concentration of the base, they gave you the sample of the acid, 25.0 milliliters, and they gave you the volumes of the bases that were used, okay? Initial minus final, okay? They give you a total volume. Very simple question. Second trial, the student initially added more NaOH to the flask that was needed to reach the endpoint and then recorded the final volume. That means that the volume of the base they use is going, this number here is going to be larger, okay? I'm sorry, I'm going to pause. The basic idea is if you add more base, you're going to assume that your acid was more concentrated, okay? I'm not even going to get into this one right now because obviously that would not be something that's on your exam right now. But if you add, if the student assumed that they needed to add more acid, that means they had to neutralize, more base, it means they had to neutralize more acid, didn't they? All right. Hope that